Good morning. Yes, afternoon. I'm going to present on my research that is ongoing, looking at the hydrochemical processes that contain groundwater chemistry within the Omder aquifer. So in interest of time, I'm going to skip the presentation outline and go straight to the introduction. Now, in semi-arid environment, groundwater serves as the most prominent source of fresh water. And within the SADC, it has been reported that approximately 70% of the 250 million inhabitants depends on groundwater for livelihood. Now, within Namibian context, we have that at least over 60% of the population relies on groundwater for domestic and social development, according to our CIMA that was done in 2010. Now, within the Rongo region, we have that groundwater constitutes roughly around 80% of that fresh water resource, and the Omdel make up at least 30% of that 80% within the region. Now, we try to actually understand how can we infer some of these activities from our hydrochemical that is being done. So we try to integrate hydrochemical approach, provide actually insight into the evolution of groundwater quality. And the objective of the study was simply to characterize groundwater quality and hydrochemical process using integrated hydrochemical process, multivariate statistics, water quality index, geospatial, and stable isotope to identify what are the natural factors that affect your groundwater potentials, quality. Now, in terms of the hydrological and geology of the study area, the Omdel is defined as a semi-confined sedimentary aquifer that occupies the lower part of our Arongo region or Maruri River, and that river spans roughly around 380 kilometers inland, and the catchment area is about 13,000 kilometers square, and is characterized as a hyper-arid semi-environment with precipitation ranging between roughly 50 millimeter per annum and the potential evapotranspiration over 2,000 millimeter per annum. Now, in terms of geology, the aquifer is within the Karali sequence, and the basement rocks is of the Damara sequence. What we have here is simply the geology of the study area, and this is how the distribution of the samples that are collected. The one we are focusing on is simply the production boreholes that are in red. So in terms of the methodology, the study utilized a quantitative non-experimental study design. About 40 boreholes were studied, and that make up roughly around 274 data set between 2012 to 2024 monitoring period. And only borehole that at least have 7 years of chemistry data were considered. And in terms of your balance charge ratio should be less than 5%. And you also ensure that your TDS was compared to the one that was done from the lab. And this is the methodology, how data were collected. We utilize data from our national monitoring network, as well as sampling that was done in 2023 to 2024. So in terms of the results, before we can go to the processes, we just need to appreciate how your hydrochemistry works. What can we get from hydrochemistry? We see that there's a high variance within your hydrochemical parameters that indicate that the water quality is actually governed by multiple geochemical processes. The pH of the groundwater is mostly alkaline groundwater system, and it also shows that we have that the basin has highly mineralized groundwater, which is ranged within your hard freshwater to hard blackish water, and the dominance of cations, sodium, and hydrocarbonates can actually simplify that there is a process of cation exchange, mineral dissolution is regard weathering taking place within your system, and also combined with that with saline water mixing. Now, to look at the hydrochemical phases, there were 2 dominant water phases that was identified, which is actually your calcium magnesium chloride water type and your sodium chloride water type. Both hydrochemical phases highly indicate that water is highly mineralized. The dissolution of carbonate and silicate plays a significant role in terms of governing your groundwater evaluations, and ion exchange plus salinity also plays a role. So in terms of the key finding from this hydrochemical phases, that groundwater quality is highly influenced by the heterogeneous hydrochemical settings and mixing of water from multiple sources. Now, in order for us to identify what are the natural processes that actually influence groundwater quality, we did some parameter plot. We did the Gibbs plot and NI sodium normalized plot, which actually highlight that most within the study period, water log interaction was the dominant process, and coupled with your evaporation rates. That is given the fact that it's a semi-arid environment with high evapotranspiration rate that is being observed. And in terms of to determine which dominant weathering is taking place, we did identify that silicate weathering was actually the common weathering process that was taking place. And then we then plotted to see which minerals are actually responsible for the introduction of the elevation of your hydrochemical within your solutions. So from this data, we have realized that the result highlighted the influence of multiple geochemical processes, such as dissolution of carbonate and silicate mineral, ion exchange, mostly your reverse ion exchange, saline water mix, and evaporation rate affect the groundwater chemistry. Now, to quantify or to evaluate the effect of ion exchange, our chlorine alkaline index was then plotted using also coupled with the Chada diagram. And then from this result, we see that most of the sample between 2012 to 2024, they were actually plotting with a positive chlorine indices. That indicates that reverse ion exchange is mostly responsible for your magnesium and your sodium and calcium concentration in groundwater. And within your chart diagram, that plotting highlight that the fact that the water chemical phases is highly regulated by your reverse ion exchange water plus your saline water mixing. Now, apart from the silicate weathering, highlight dissolution and reverse ion exchange greatly also govern your geochemical process. Evaporation also plays a significant better role within the study area. Now, to see the stability of the mineral indexes, we look at the key, based on the geology, we look at the key carbonates, your silicates and your sodium minerals. And we see that from this data, we realize that most of our carbonate minerals were oversaturated in groundwater. That means they have the ability to precipitate. And then most of our evaporated sodium fluoride were undersaturated. That means they have the ability to dissolve within groundwater. Now, the key finding from this, again, the influence of groundwater quality in the region are governed by precipitation of carbonates and silicate mineral, as well as your ion exchange and dissolution of your sulfide, halide, and fluoride minerals. Now, we further look at, is there any influence from your anthropogenic, given the fact that the catchment area extends significantly within the inland whereby agricultural activity is taking place? So we looked at in terms of, we plotted in terms of to see, looking at your nitrate concentration. From that, we realized that even though agriculture is a major factor within the catchment area, it has minimal influence on groundwater quality that is observed within the basement. So, however, the salinity, within the salinity, we realized that it was highly moderate to saline water, and then generally, most of the boreholes were slightly or moderately affected by mixing of saline water. Just to look at it in terms of the origin of water that is recharging our aquifer, we then have to sample for isotopes that, because they don't form part of the monitoring period in terms of the national network. And two clusters of groups were identified, your downstream cluster and upstream. The downstream cluster actually made of the boreholes that are closer to the shoreline of the Atlantic Ocean, and then your cluster 2 is more of the upstream borehole that are actually closer to the infiltration ponds. And then we then use hazy characteristic analysis and factor analysis to see what can we see from that. And then we also realize from there that natural geochemical process is actually the main dominant aspect. And then there were three factor analyses that were identified that have a total variance of at least 85%. And the degree of mineralization actually showed that downstream samples have better water quality compared to your upstream. And what we found out from this aspect that the upstream sample, even though they are closer to the infiltration ponds that are designed to recharge the aquifer, they still extracting water from the old groundwater. They are quite deep, and that is the reason why they are highly mineralized, and there is a presence of saline water mixing in those boreholes. And this, in terms of, to conclude, the study provided an integrated assessment of the OMDEL, combining hydrochemical multivariate statistic analysis, and then groundwater erosion highly governed by precipitation of carbonates, silicates, and ion exchange, saline water mixing, and then your dissolution of your halite, sulfite, and fluoride minerals. The result also highlight the absence of significant anthropogenic activity influence from the catchment area, and the groundwater is of evaporated meteoritic origin, and generally, the groundwater of the basin is characterized by a good to poor water quality index. And then in terms of the finding of the study contributes valuable knowledge to the support of the National Water Corporation of Namibia, NAMWATER, and the Department of Water Affairs in resource planning, monitoring, and management. And I just want to give acknowledgement to the company that played the roles in this study, NAST, UNAM, our Minister of Agriculture, Water, and Land Reform, and NAMWATER for being the technical sponsor of the study. Thank you.